So inequalities, there are four inequality symbols that we typically talk about, aside from the not equal sign. And they are, so it's less than or equal to, greater than or equal to. Now, it can be sometimes confusing. It's like, well, is it pointing to the left or pointing to the right? It's like, okay, I can get that. Um, if you're reading and you get to a point, so if you're reading left to right and you get to the point, that is a less than. When you put the line underneath it, that makes it or equal to. Okay. Again, if you're reading this way and you get to the open part, that is a greater than. So the open part is greater than. And then again, if you put the line under it, greater than or equal to. Okay. So we're going to decide between the less than or the greater than symbol, which one goes in between these two pairs of numbers. Well, I guess we have three. So between 5 and 5.1. And the thing, right, so you don't really have to remember, is it a greater than or less than? You just want to open towards the bigger one. Point at the smaller one, open to the bigger one. Right, so 5.1 is bigger, so we will open towards that. Point to the little one. All right, now -3 and -2. Negative numbers and inequalities can be challenging. So I have a number line right here. I'm going to go ahead and I'm going to put 0 in the middle just because I've got a couple of things that I'm going to use this for. And then I'm going to start marking off a little bit. I'm not going to go too far because I don't have that many numbers to deal with. In fact, that's enough. And now if we look at -3, right, is right here. -2 is right here. So the numbers to the right are the bigger ones. So -2 is bigger than -3. So it is greater than -3. So I'm going to go ahead and open towards the greater number, to the bigger number. Now, 1/3 or 1/4, which one is bigger? So let's think about that. Which one would be, right, so if that's 1/2, so 1/4 is closer to 0 than 1/3. And again, you can think about it, right? If it's pie, would you rather have 1/3 of a pie or 1/4 of a pie, right? Well, if you're like me, you would rather have 1/3 because it's more. So in fractions, if the numerators are the same, again, if we're positive, if numerators are the same, right, the bigger the denominator, the smaller the fraction. Okay, so once you kind of get a handle on what it means to be greater than or less than, which way we point, there are some new notations. So I'm going to go ahead and we're going to talk about, right, the inequality and how we can write it in set builder notation, what the graph looks like, and then maybe for some of us, a new notation called interval notation. So here's the inequality. X is greater than, right? I get to the open part, I say greater than. X is greater than 9. So what we're talking about is the set of numbers, all of the numbers, right, that are greater than 9. Okay, so set builder, all we do is we take that inequality and we just put some decorations on it. Okay, so we use curly Q braces when we do set builder. So this, because this means set. So the curly Q braces just mean set. So the set of all x's such that x is greater than 9. That's it. Okay. What the graph looks like, and you can put the 9 anywhere. You don't have to give me any more numbers. I'm assuming you could if I asked you to. So I want 9, and then I want to be greater than 9. So which side of the line has the numbers that are greater? Right? Exactly. To the right. Now, if you haven't done these for a while, you might have used an open circle on the 9 to say not 9, but everything to the right of it. Well, now, just because, right, it can get confusing, it's sometimes hard to see that, right, orange line that I've drawn on the right side. So what we do is we're going to use a parenthesis to say the start here, but don't include 9. So the parenthesis is the new open circle. Okay, And then interval notation. So interval notation, it has a certain syntax, right? A certain way that you write it. And what you do is you're going to put the smallest number, so the least number that's in your set. And so for us, that's 9. And I know I hear you. You're saying, but 9's not included, Angela. I know. So what we do then is we put a parenthesis on the 9. It said 9, but not really 9, just the next number up. And the next number up isn't necessarily 10, right? Because it could be 9.0001. And I need all of those decimal versions that come after 9, between 9 and 10. So 9, but not including 9. And then it goes on forever to the right. So the number that's forever to the right is infinity. And infinity always gets a parenthesis. Okay, so smallest number, comma, largest number. And then if the number is not included, we do the parenthesis. Infinity is an idea. It's not actually a number, so it always gets the parenthesis. Okay, next one. X is less than or equal to 4. So the set builder, right, is super easy. We just add those parts in. Set of all x's, right? That vertical line that I snuck in there, we read such that x is less than or equal to 4. The graph, go ahead and grab 4. So now I want the numbers that are less than or equal to 4. So I'm going to go to the left of 4. And now to say, so if a parenthesis is not including, the including is a squared off bracket. And notice how this time I have my tabs. I have it kind of pointing in the direction of the solution set. It's another clue for people who see the graph. It's like, oh, I don't have to try to decipher which way you drew your line on top of the number line. I can see that we're going to the left because that's the way the tabs go. Okay, so now to describe this set in interval notation, I need the smallest number, right? So the one furthest to the left. And since it goes on forever to the left, that would be negative infinity. Notice a parenthesis again. And then the right number is the biggest number. And the biggest number is 4. And we do include it. So we say that with a squared off bracket for it. Okay, last one. 8 is less than or equal to x. Oh my gosh, I just don't like that. I like my x's to be on the left when I'm doing inequalities. I just feel better. Okay, so here's what I'm going to do. I'm just going to take this and I'm going to rotate it. So I'm going to take the whole thing and kind of pivot it this way, 180 degrees. So x, in this inequality, it's right, has the open side. So I'm going to go ahead and keep it opening at the x, pointing at the 8. So now I see x is greater than or equal to 8. Set of all x's such that x is greater than or equal to 8. The graph, right, put the number of interest 8. I want the x's that are bigger than 8. So that's to the right. We're including 8, so we put a square bracket. Okay, smallest number 8 with a bracket. Largest number, infinity, 8 on its side. Okay, so now if we have a linear equality, right, that looks like kind of our equations, but with an inequality symbol as well, we're going to use those same properties that we use to solve linear equations with one fine print thing. So my fine print, if you, okay, need to multiply or divide by a negative number. So in your solution strategy, if one of the things that happens is you multiply both sides by a negative number, or you divide both sides by a negative number, you will flip the direction of the inequality. Okay, so I'm sure I'll have an example for us to practice that. So let's do the first one though. So remember our properties of equations, so the addition principle and the multiplication principle. So 2x plus 3 is less than 15. So we want to get the x by itself. So that means the first I'm going to isolate the x term. I'm going to move the plus 3. So to get rid of that, I would subtract 3 from both sides of the inequality. So 2x is less than 12. And now to get, so it's 2 times x. So to get the x by itself, I would divide by 2. Same thing to both sides. x is less than 6. Okay. So then to make that in interval notation, which is typically how we're going to be writing our answers. So there's my, I usually go with a number line just to kind of ground myself. So I have my 6, I want less than, not including 6. So forever to the left, that's negative infinity is the smallest number, up to 6, but not including, right, because my inequality didn't have the or equal to. So that's the set of numbers, right? If you pick any number in this set between negative infinity and 6, and you plug it in to this inequality statement, you would get a true thing. So you could take 0, or you could take negative 2, you could take 5.9, right? Any of those numbers in that set is going to make this true. Okay, next one. 7x plus 1 is greater than or equal to x minus 10. So I have two x terms, one on each side. I need to bring them together. I will typically keep my x's on the left. Again, that's just my thing. It makes me feel better. So subtract x from both sides. So when you're moving terms, you add and subtract. So 6x plus 1 is greater than or equal to negative 10. Again, I'm going to move the plus 1, so I will subtract 1, moving the whole term. 6x is greater than or equal to negative 11. 6 times x, and now I have a factor that I'm moving, so I do that with division. So I'm going to divide both sides by 6. So I have x is greater than or equal to negative 11 sixths. I know it's an ugly number, but it doesn't matter, right? We just have to write it down. So let's go ahead and do it. So think about what the graph would look like. Negative 11 sixths. And we want to be greater than or equal to. So negative 11 sixths to infinity. That's how we would write our answer. Okay. I know this is like a kind of answer, right? You've solved it. You found the set of x's. This next step is just, right, putting it in a certain notation. Okay, last one. So here we're going to practice our fine print. So negative 5x plus 1 is greater than 8. So we're going to subtract 1 from both sides, get the x by itself. So negative 5x is greater than 7. Now, to get the x by itself, I need to divide by the negative 5, right? So I'm going to divide the left side by negative 5. I'm going to divide the right side by negative 5. And when I write this down again, not only am I going to do all of the correct sign flipping that we have, but I'm going to flip the way the inequality symbol points. So I'm going to have x is less than negative 7/5. You can go ahead and leave the negative sign down with the 5 if you want. Okay, so that's kind of how that works. I'm not going to write that in interval notation because I wanted to show you one more thing. I just kind of want to show you why this is a thing, why we need to do that flipping. So I'm going to go back to the, so the negative 5x plus 1 is greater than 8. So we could solve this a different way, right? We could go ahead and add 5x to both sides, doing the same thing to both sides so it's not right, wrong. So now I have 1 is greater than 8 plus 5x. I'm going to subtract 8 from both sides. So now I have 5x by itself on the right. Eek. Then I have my greater than symbol. And then I've got negative 7. And then my next step would be to divide by positive 5, right? So I'll have negative 7/5 greater than x. Okay? So these two are equivalent. Right? So that's why we needed to flip the direction. If we wouldn't have flipped it, this symbol would have been pointing at the wrong number, right? It's pointing at the x, pointing at the x. Okay. So when you multiply or divide by a negative number, flip the way the inequality symbol points.